In this video, I'd like to discuss parallel lines. Now, in the plane, remember a plane is, think of it like an infinitely long sheet of paper. You can have lines, and lines, there's really only two possibilities for pairs of lines. Either two lines will cross, or two lines will be, they won't cross, so they'll be in the, they have to be in the same direction for that to happen. Okay, so if they cross, another word for crossing is that they intersect. So lines can either be intersecting or they can be in the same direction, and we refer to that as parallel. So intersecting lines and parallel lines, those are the only two options for two lines, any two lines in the plane. Now we'll see that in 3 dimensions there's a third option, but for right now there's in the plane there's only two. Okay, now if you have two lines, and let's say you have a third line that intersects both of those two lines, all right, maybe they're intersecting, maybe they're parallel, but you have some interesting properties that we will be referring to. Let me go to a new whiteboard. Let's say you have parallel lines, all right, and let's say you have another third line that chops or intersects both of those. So whenever you have a line that intersects two other lines, that third line is referred to as a transversal. You can have a transversal that intersects two crossing lines. You can have a transversal that intersects or crosses two parallel lines. Okay, now I want to now focus on the transversal that intersects a parallel line, two parallel lines. Okay, notice that you have 8 angles formed. Let me label them: 1, 2, 3, 4, 5, 6, 7, 8. I want you to think about which angles are congruent, if any, which pairs, which ones are supplementary, if any, and why. See if you can prove your assertions, and that's what we'll discuss in the next video. We're going to discuss all the interesting properties of the angles created by two parallel lines cut by a transversal. Remember, parallel lines means the two lines are in the same direction.